Hello there, this two-part tutorial series will teach you how to create a fully physics-based upper body, like this you have in BONEWORKS, GORILLATAG or a Blade and Sorcery. The first episode will explain to you the underlying principle of how everything will work and how to implement the technique, which will give you a very solid GORILLATAG clone. The next episode is going to show you how to mount the upper body on every character controller you want and how to combine the physics-based body we were creating in the last two episodes with the upper body we're going to create in this episode. The core principle of how everything will work are active ragdolls. In active ragdolls, you have a rigged 3D model that performs an animation. In our case, we won't use a fixed animation, but we want to dynamically move the 3D model's bones so the hands reach a specific position and rotation. We'll achieve that by using inverse kinematics. On the other hand, we'll need a second 3D model that is a ragdoll. A ragdoll means it's not just a mere model, but it has physics components so it can interact with the game world. Having those two components, we want the ragdoll to mimic the 3D model's animations. So let's get right into it. I won't cover how to set up a Unity VR project in this video. If you don't know how to do this, check out the first link in the description. Select the main camera and set the tracking type to rotation only. If you have it, also delete the simple camera controller. Next up, import a 3D model. You can basically use any humanoid 3D model that you want, but I highly encourage you to use the same model as I did. I advise that because some of the scales I'll apply to the body's limbs won't translate well to other models. You'll find the model I'm using over the link in the description. After importing the model, extract the materials. Create an empty game object, name it player, and set its position to 0 on every axis. Drag your model inside the player game object, name it model, and unpack it completely. Open the package manager and download the animation rigging package. After completing the download, you want to select the model and click Bone Render Setup under the new Animation Rigging tab. If we were not tweaking a few scales, the model would look quite small. That's why you want to select the model and scale it up to 1.21 on every axis. We won't need legs, so select them too and scale them down to 0 on every axis. Select the upper arms and set their scale to 1.1 on every axis too. The hands would look uncannily big, so you want to set their scale to 0.8. And now we are going to create the IK rigging. Select the model and click Rig Setup under the Animation Rigging tab. Then select the rig under the model that Unity was creating for us and create two empty game objects that you want to call right hand and left hand IK constraint. Add a 2-bone IK constraint to both game objects. Select the right hand IK constraint and move the model's right hand into the tip component of the 2-bone IK constraint. Right-click the 2-bone IK constraint and select Auto Setup from Tip Transform. Do the same thing for the left hand too. Select the left hand's IK constraint hint and the left forearm of the model. Then click Align Transform in the Animation Rigging tab and repeat that for the right hand. Select both hints and offset them a little bit like shown in the video. If you hit play now, you can see that the arms are trying to reach the IK constraint's target. Next up, we're going to create a ragdoll. Close the model hierarchy. Select the model and copy-paste it within the player parent. Name it physics and delete the rig game object in its hierarchy. Select the right and left hand, forearm, arm, and the physics model itself. Then add a rigid body to all of those components. Make sure the rigid body is set to interpolation. Select the right and left forearm and add a capsule collider to them. Set their center to 0.115 on the y-axis. The radius to 0.03 and the height to 0.23. Select both hands, add a box collider to them and set their center to 0.005 on the x and 0.11 on the y-axis. The size should be 0.1, 0.22, 0.05. Select the right hand and set the center to minus 0.005 on the x-axis. Now we are going to join the limbs together. Select the right and left hand, forearm and arm. Then add a configurable joint to them. Lock the X, Y and Z motion of all joints. Set the angular X and YZ drives position spring to 6000 and the damping to 50. Disable preprocessing. That will make the joints behave more accurate. Select both hands and set their angular position springs to 1000. Next up, connect all joints in that scheme. Hand to forearm, forearm to arm, arm to the physics root. Select a player and create a capsule. Name it body. Set the position to 1.6 on the y-axis. And set its scale to 0.2 on every axis. Add a rigid body to it, set it to interpolate and freeze the rotation on every axis. Add a fixed joint and connect it to physics. Select physics and create 3 new layers. Create a body, a right hand and a left hand layer. Select the physics and body game object, then apply the body layer to them. In the dialog window, choose Yes, Change Children. Then select the right hand, forearm and arm, and apply the right hand layer. Do the same thing for the left side. Open the project settings. Set the solver iterations to 255. Of course, you can go lower, but the joint accuracy will be decreased if you do so. So try to set those values as high as possible. Set the angular speed to 100. Forbid self-collision of the right hand and the left hand layer. Also forbid collision between the body and the hand layers. If you hit play now, you can see that we have two separate models, of which one is a model that tries to reach a specific point, and one is a ragdoll. Close the model and the physics hierarchy. Then select the player and add a script to it that you want to call hand control. Open the script. First of all, you want to import a bunch of stuff like shown. In update, collect all the inputs you'll need, like shown. Set the model's position to the physics position. Set the camera's position to the head position. The targets will determine which point the IK ring should reach. Set the targets to the head position, plus the difference in position between the hands and camera. Set the target's rotation to your hand's rotation. Go back into Unity and apply all components you can to the script. That means the left and right controllers, physics, model, and the left and right inverse kinematics targets. You can see that the head and the camera controller is missing, so let's create them. Select the camera offset in your XR origin and create an empty game object which you want to call camera controller. Add an action-based XR controller to it. Check the position action use reference, and as reference use XRI HDM position. Check the rotation action use reference and set the XRI HDM rotation as reference. Add the camera controller to the script. Outside all hierarchies, create an empty game object that you call head. Set its position to 1.9 on the y-axis and to 0.12 on the z-axis. Move it inside physics like shown. Add the head to the script. Add a new script that you want to call movement. We'll create that separate script since it will make things easier when we'll apply the character controller. Open the script. Make the same imports as I did. Get the camera's rotation. Set the model's rotation to the camera's rotation on the y-axis. Do the same thing for the body. Back inside Unity, apply the camera controller, body, and model. If you hit play now, you'll see that you can turn around and move your model's hands. Still, the model's hands are a bit offset and physics isn't doing anything. So let's do that. Select the right and left hand, forearm and arm. Then apply a script to them that you want to call target limb. This script will enable physics to mimic the model. Open the script. In the beginning, store the initial rotation of the limb we want to mimic. In fixed update, set the configurable joints target rotation to quaternion inverse of the target's rotation times the initial rotation. Back inside Unity, select the right hand of physics and apply its model counterpart to the script. Do the same thing for the left hand and the left and right forearm and arm too. If you hit play now, you'll see that you can drag yourself over the ground with your arms, like in Gorilla Tag. Still, we can see the model's mesh and the hands are still offset, so let's fix that. Inside the model, select CH36 and delete its mesh. Select the player and create an empty game object that you want to call hands. Inside hands, create two empty game objects, right hand and left hand. Move the right IK constraint target inside right hand and move the left IK constraint target inside left hand. Select the right hand target and set its position to -0.05 on the Y and -0.15 on the Z axis. Set its rotation to -90 on the Y and Z axis. Select the left hand target and set its position to -0.05 on the Y and -0.15 on the Z axis. Set its rotation to 90 on the Y and Z axis. Select the player and use the right hand inside hands game object as right target. Use the left hand as left target. And that's it. If you hit play now, you'll see that you have a pretty solid Gorillatac clone. Check out the second episode to learn how to mount the body we were creating onto every character controller you want. See you!